Hello, everyone. Welcome to Agones, scaling game servers with Kubernetes. My name is Mark Mandel. I'm a developer advocate at Google Cloud, and thank you so much for spending time with me today. So, what do we want to talk about? Today, we want to talk about fast paced multiplayer games. So, I'll give you a little bit of background on this. It's a very quick overview. Traditionally, your architecture for, say, a fast paced online competitive multiplayer game, say maybe like your Fortnite or your Overwatch or something like that, will look something like this. So, here we have a couple of players. They probably want to play a game. Uh, they will connect to something called a matchmaker, probably something you're very familiar with. And the job of the matchmaker is to pair them up and basically group together people who are like a good fit for playing a game, maybe based on their skill level, who their friends are, etc. And once we've match made those players, what we're then going to do is talk to a system that is commonly referred to as something like a server manager. This thing is a thing that is going to provide us with what we commonly refer to as a dedicated game server or an authoritative server. Basically, the job of this server is to track everything that's happening inside our fast paced game so we can send that information back to the players that are playing it. So it's going to look across a huge slew of machines and basically say, hey, I need one of these. What CPU do you have available? What memory do you have available, etc. I'm going to grab one of them, grab its probably its IP address and its port details. And then I'm going to send that back up to the two players. So those two players can then connect directly to that dedicated game server and they are able to play a game. Now, unfortunately, a lot of the time when people are building this stuff out, um, it tends to be sort of bespoke. People sort of build it themselves. But wouldn't it be kind of nice if we could leverage something to do some of the work for us in this particular area? So the area we're actually going to talk very specifically about today is this area. We're going to look at that server management to dedicated game server scaling solution. And we're going to talk about a little open source solution for making it a little bit easier for you to orchestrate and scale your dedicated game servers. So what's the thing we're actually going to talk about? We're going to talk about a thing called Agones. As you can see here from the description on the page, Agones is a batteries included open source dedicated game server hosting system. It's kind of cool. Basically, yeah, if you want a platform that is open source for you to be able to run your dedicated game server workloads with all the bells and whistles that you might need to do so, Agones is a great open source project to do that. So we're going to dig into Agones a little bit, talk a little bit about some of the features and some of the things that are available in it, so you can get a bit of a sense of what it is that it does and how it works. So first things first, important thing to note, many of you are probably already familiar with the project Kubernetes. It's another open source project for running basically any kind of backend distributed system. If you're not familiar with Kubernetes, it's really just a really cool way of being able to run software across a whole bunch of different computers. But Agones sits on top of Kubernetes. This is exceedingly important because that means we can take advantage of the whole ecosystem of Kubernetes, but we can extend Kubernetes so that we can teach it how to run game server workloads and give it all the extra bits and bobs that it needs so that it understands how to do that and can manage them accordingly, which is hugely powerful. Kubernetes just gives us so much out of the box, and so we can really focus on building a platform that works for game server workloads. So if you want to get started, what's sort of the flow here? So probably unsurprisingly, if you've done anything with Kubernetes, first step is containerizing your game server. This is especially cool because this means that you can run whatever it is you need to run with your game server as long as it's inside a container, which is nice. Once you've got your dedicated game server, you put it inside a container along with any other dependencies or anything else it might possibly need. It's in a nice little artifact that's easily shippable and can be run on top of Kubernetes and therefore run on top of Agones. We do have an integration SDK. It does some nice things in there around like being able to mark whether a game server is ready, whether it's shut down, check its health status, be able to get access to configuration information, and more. That is a part of the integration step as well as containerization. But we have a whole slew of different integration patterns that are available and integration languages and SDKs. So, the big ones, Unity and Unreal, they're all there if you need C++. But if you need other languages, they're available too. And even if we don't support a language that you use, we have both gRPC and REST endpoints that you can call directly as well. So This wouldn't be a Kubernetes talk if we didn't show some YAML. So how do I create a game server with Agones? So if you want to create a game server inside Agones, I'm going to show you how. If you've done anything inside Kubernetes before, you've probably seen some YAML. So here's some more. If you're not used to Kubernetes, Kubernetes is a declarative system. Basically, we tell it what it is that we want and make sure it happens for you. So in this particular instance, now that we have installed Agones, we're able to say, hey, give me a game server. And we can specify its details. So in this particular instance, what we're doing is we're going to create a game server named Sonotic. Sonotic is a great first-person open source shooter game that we'll show a demo of a little bit later. And then from there, what we're able to do is specify a whole bunch of different configuration information. In this example, we're specifying the port that the game server is available on. It's 2600. Agones is going to take care of dynamically allocating a port that the game servers can connect directly to the node specifically. They don't go through a load balancer or anything like that. Agones takes care of that. And then from there, what we're able to do is specify one or more containers that are going to make up the game server itself. Here, we're going to use a Sonotic example container that's part of Agones, and we'll actually see in action a little bit later. But we can take this one step further. Usually with game server workloads, what you want to do is actually run a large group of them. Sometimes they can take a little while to spin up. So you probably want to have a few of them ready. And for that reason, we have what we commonly refer to as fleets. Here again, we have a YAML file. Everything I'm showing in YAML as well, you could do programmatically. There's a variety of interfaces there, but YAML is just nice for demos. And creating a fleet is very simple. Fleet is really just how many game servers of a particular type do I want? Here I'm creating 2, nothing more than that. And below that, inside the YAML, I have the template, which is my game server template. So all the stuff we had before, I can also put in here that basically defines the game server I have. And again, declaratively, we're telling the system, hey, this is the number of game servers I want to have. Make sure I have this number at every given point and time. Now, we have a whole bunch of stuff around auto scaling and all kinds of stuff. I'm not going to worry about that today. Don't even worry about it. Just be aware that it's there if you want to dig in further. Now, there's one very special thing we need to talk about real quick as well, which is allocation. The very special thing about game servers, right? If you don't have players playing on a game server, nobody cares if you shut it down. If you do have players playing on a game server, people really care if you shut it down because you're going to interrupt their gameplay. So we have this concept called allocation, which is an imperative command that basically says, hey, go look at the game servers we have, pick one out from a set. Here we're actually saying everything that has everything from the fleet Sonotic, so a really simple selector here, and give me one back and mark it as allocated. Marking it as allocated is the important step because anything that is marked as allocated within the Agones system, we know has players on it, and so therefore we're going to make sure it stays alive until it shuts itself down. This is important because then that means you can do rolling updates, you can scale your fleet up and down without having to worry about interrupting your game server, and therefore not interrupting your players, which is super, super important. So why don't we quickly show you that in action with a little demo so you can see it, and we'll also just play a game. So here I've already got a Kubernetes cluster that's got Agones installed already. And since I have Agones installed, I can say kubectl get game servers. Now, those of you who aren't familiar with Kubernetes, kubectl is the command line interface that lets me interact with my Kubernetes cluster. And because I have Agones installed, I can ask for game servers. Now, strangely enough, we don't have any in there, but we saw earlier we had that fleet of Sonotic game servers that we were talking about before. So let's install that. This is the fleet YAML that we saw previously. I'm going to just apply exactly that. That's going to create 2 game servers for us right away. So let's now have another look. Get game servers. Again, I could be doing this programmatically through some sort of API, but YAML is just kind of handy. They're currently scheduled. They should come up as ready in a second. There we go. And they're up and ready. They've loaded all their in-game data. They're good to go. I can scale this if I want. Let me say, maybe I want 5 instead. I can scale it up and down, all that kind of good stuff. But let's Now we have lots. But let's talk a little bit about allocation, because I think it's actually easier to see and understand when it's in front of you. So we've got 5 game servers, awesome. But we actually want to play a game of Sonotic. So we want to make sure that game does not get interrupted. So usually this would be something you'd interact or integrate with your matchmaker, but we're going to do it just through YAML because it's just a bit easier to show. So I'm going to create the game server allocation we were looking at before. So examples, Sonotic game server allocation, and I'm going to say spit out the response in YAML. So this is the one that would look through the Sonotic fleet and just pick the most appropriate one to hand back to you. So why don't we do that? Here, I'm going to just run that right now. So that's going to spit out a bunch of stuff, but the most important bit is down here, where we can see, okay, it states allocated. So it's special, it's got players on it. We can see the game server name. We've got an IP and port there, but maybe a nicer way to look at it here is kubectl game servers. And we can see, okay, there's that one that's allocated out of the set. So that means we could scale this down, we could do an edit to our fleet, and it would roll through, but it wouldn't stop this game server specifically. So, you know what? Let's actually play a game. Fire up Sonotic. Pop back over here. Beautiful. Now, assuming I can type well, 35.197.72.243. What's the port we're using? 7257. 7257. Boom, boom, boom. Let's join. So that's going to connect to the dedicated game server that I have running. I think it's US West. Never quite remember. Running the dedicated game server specifically for Sonotic. So here we can see it now. There's a few other bots floating around. So let's go see if we can find one. Oh, there's one. Here you are. So this is just very simply a multiplayer game that's running on top of the Agones system. There we go. At least I get one. Give me one. Perfect. Excellent. So as you can see, I'm able to play this game, Sonotic, here on top of Agones. So I'm gonna shut that down. Okay, so that was super cool. I'll show you another really cool little thing as well. So if I want to scale this fleet back down like we saw previously, so I send it back down to 0. If we have a look at what's happening there, we can see that all the other game servers are shut down except for that one we were allocated. Again, very special. If we actually look at this over time, it's going to get smaller and smaller, as we see here. So that game server is never going to go away until it is specifically deleted. And this is one of the powerful things that Agones does, is enables you to manage that life cycle of game servers so that when players are playing a game, they do not get interrupted. Awesome. All right, so let's wrap things up before we finish. So we only scratched the surface of what's available on Agones, but some other highlights of features available too. It works across cloud providers because it just works on standard Kubernetes, so you can put it where your players are. We talked a little bit about some of the auto-scaling stuff, but that's all there. You have a lot of control there as well. We've also got a bunch of local development tools if you want to be working on Agones without a full setup, trying to make that iteration loop faster, metrics and dashboards, all kinds of other cool things that are available. So if you want to learn more, you can follow us on Twitter at AgonesDev, but you can also go to the website agones.dev, where you'll have links to the GitHub, the Slack, the mailing lists, our community meetings, everything and more. We'd love for you to come down, come check out the project, give us some feedback, get involved, and just hopefully you can make some really cool games and work on them at Agones. All right. Well, thank you very much for your time, and I hope you enjoyed the presentation.